Hello there, and welcome back to Sleepy Science Stories. I'm glad you've arrived tonight wherever you are, and however your day has unfolded. The lights are dim now. The noise of the day has softened. You are here listening, resting, breathing. Out there beyond our quiet sky, something rare is moving. A small silent traveler, not from our solar system, but from another sun, another world. It drifts through space like a whisper between stars. Astronomers have given it a name, 3I Atlas. Only the third interstellar visitor we've ever seen. A fragment of another sky passing through ours for just a moment. It carries a story older than our planets, a message written in ice dust and motion. If you find calm in these quiet journeys through the stars, a soft tap on the like or subscribe button helps other sleepy minds find their way here too, one gentle traveler at a time. So as your body settles and your breath slows, let your thoughts drift with this visitor turning quietly through the dark between worlds. You don't have to move. You don't even have to stay awake. Just listen and drift. The universe will wait. The story of 3I Atlas begins quietly, as most cosmic stories do. Not with thunder or light, but with a faint sequence of pixels, a few dim points caught by a telescope high in the Chilean desert on a winter night in early July 2025. The Asteroid Terrestrial Impact Last Alert System, known simply as ATLAS, is designed to watch. Each night it scans the sky for motion for the slight shift of a dot between frames, the signature of something wandering through the dark. On July 1st, one of those frames showed a visitor that did not belong. At first it seemed ordinary enough, a moving object, faint but steady, gliding against the slow background of the stars. But its path did not curve as expected. It did not bend like the orbits of asteroids, nor swing in the lazy ellipses of comets bound to our sun. Its course traced a hyperbola, a line that comes in from infinity and returns to it again. The mark of something not from here. It took only a few nights for confirmation. The speed, the angle, the gravitational fit. Everything pointed outward, away from home. Another interstellar object, the third ever seen after Oumuamua in 2017 and Borisov in 2019. And so it was given a name that carried its lineage. 3I Atlas 3 for Third Interstellar and Atlas for the system that first caught its glint. You might imagine that by now, discovering something from another star would feel familiar, but the sky does not repeat itself easily. Each interstellar visitor has arrived with its own strangeness, its own quiet refusal to fit our patterns. And this one, even from the start, seemed to hum with a quiet contradiction. From the coordinates of that first night, astronomers traced its direction backward, searching for the star it might have come from. The result was curious. The path lay almost perfectly within the ecliptic plane, the flat disk along which the planets travel the thin stage where our solar system performs its endless motion. That was strange. Most interstellar travelers arrive from random inclinations diving in from the galactic field at steep angles. But 3I Atlas moved as if it already belonged, as if it were born to this flat celestial geometry or drawn into alignment by something unseen. Of course, alignment alone does not imply intention. The sky is full of coincidences that look like design from a distance. Still, many observers felt a quiet unease. The ecliptic plane is not a large target. To strike it so precisely is rare a thread through a cosmic needle. So they began to watch more carefully. Each night, Atlas and its companion telescopes recorded the object's growing brightness as it approached the inner solar system. The light was steady, its magnitude changing in ways that hinted at a rotating irregular body, a small mountain of rock and ice roughly 3 to 5 kilometers wide. That's about the size of Manhattan Island, but moving at 60 kilometers per second too fast, too cold, a monument adrift through sunlight. It glowed faintly and reflected light, its color leaning slightly blue, the tint of frozen carbon dioxide and water ice. To most people, a new comet or asteroid passes unnoticed. But among astronomers, these first weeks felt like the quiet rise of a new chapter. Each interstellar object is a message, a sample from another system, a memory from elsewhere in the galaxy. Where Borisov was a true comet, icy venting behaving as physics would predict. And Oumuamua was a mystery of acceleration and silence. This 1-3, Atlas, seemed to blend the two, neither fully one nor the other. Its orbit told the tale of an outsider, but its surface began to whisper of activity. As sunlight reached its frozen face, a faint envelope of gas emerged. Not dramatic, not the long tail of a comet, but a localized shimmer. It appeared to breathe to release something from its heart. This was no surprise at first. Most icy bodies vent as they near the sun. Frozen volatiles turn to vapor. Jets of gas carry dust into the surrounding space. But the direction of those jets, that was where the strangeness began. When a comet vents, the gas escapes away from the sun, pushed by solar heat and radiation. The tails always trail behind, turning outward into the dark. But 4-3i Atlas instruments recorded something almost impossible, a jet pointing sunward. It was subtle, barely perceptible at first, but persistent over days and weeks. A plume of material extending toward the light as though the body were pushing against the direction it should naturally yield to. And yet, despite this activity, its motion through space remained unchanged. No measurable non-gravitational acceleration, no sign of recoil from the venting, no drift from the predicted path. For a small object expelling gas at such a visible rate, this stability was astonishing. Some suggested that the jets must balance each other, a symmetrical venting that cancels the push. Others proposed an unusual mass, a dense interior, perhaps metallic so massive that no plume could sway it. But those answers only deepened the mystery. For a body of 3 to 5 kilometers and an estimated mass of 33 billion tons, even small continuous jets should have left a trace. And yet nothing. It drifted with the serenity of a planet as though perfectly content with its path. Quietly, calmly, predictably. A contradiction that became its signature. Observers began to imagine its structure. Was it a fractured comet, its jets emerging from shaded craters where pressure built unevenly? Was it a solid metallic core wrapped in thin layers of ice that vented from micro-fissures, or something entirely else, a kind of engineered surface that regulated its own motion? No one could say. The telescopes gathered light, but not certainty. The more precisely they measured, the less sense it seemed to make. Still, there was beauty in the confusion. Science, when it slows to wonder, becomes a kind of meditation, a quiet acceptance that the unknown is not an enemy, but a landscape to rest within. Through July and August, the object's path curved gently inward. The sun's pull slowed it slightly, but not enough to capture it. Interstellar objects usually glide through on brief parabolic visits. They enter fast swing around the sun and are gone forever. Their hyperbolic trajectories are the fingerprints of escape. But as data accumulated, small deviations began to appear. Not random noise, but a consistent, gentle deceleration. It was as though 3I Atlas were easing its pace, letting gravity take hold a little more than expected. At first, the numbers were dismissed as calibration artifacts, the way a heartbeat in a telescope mount can mimic a shift in velocity. But by early October, the pattern was undeniable. The curve of its path had begun to round. If this trend continued, astronomers realized the object might not leave. It might be caught drawn into a long looping orbit around the sun, a temporary capture. No such event had ever been confirmed. Every known interstellar visitor had entered and departed untouched by the sun's gravity beyond the brief slingshot of a flyby. But 3I Atlas seemed to be breaking that rule. By mid-October, predictions centered on two key moments. October 21st, solar conjunction, when the object would slip behind the sun, hidden from all telescopes on Earth. And October 29th, perihelion, its closest approach to the sun, the turning point of its orbit. Between those two dates, no one could see it directly. It would move behind the glare veiled by the same light that had revealed it. Astronomers weighted their models, whispering possibilities. If it re-emerged on the far side with a closed curve-abound orbit rather than an open one, it would mean the impossible, that an object from another star had become for a time part of ours. Imagine that for a moment, a wanderer from interstellar space slowed just enough to linger in sunlight. A cosmic visitor deciding, perhaps by accident, to stay a while. As the days passed toward conjunction, observatories around the world watched until the final possible moment. Each last frame was a fragment of farewell, a brightening point just above the solar glare, then gone. Its light folded into daylight. Its path continued where eyes could not follow. Even in that absence, it inspired the same quiet awe that comets once stirred in ancient skies. Not fear, but a sense of being witnessed by something profoundly other. An object unbound by our history, carrying materials older than our planet's crust, now gliding through the same light that touches the oceans and trees below. When data alone cannot fill the silence, humans imagine. And imagination in science is the seed of discovery. Researchers began to model how such an object could lose enough speed to fall into a solar orbit. Was it venting in a way that subtly countered its velocity, a natural braking mechanism from the strange sunward jet? Or was it encountering regions of denser interplanetary dust, creating a gentle drag unmeasured before others speculated about electromagnetic effects or transient magnetic coupling as it crossed regions of the heliospheric current sheet, a broad, invisible wave of charged particles flowing outward from the sun? None of these explanations satisfied completely. Each required coincidences too delicate, too finely tuned to fit comfortably. Yet the universe often balances on improbable harmonies. By then, the name 3I Atlas had become a quiet melody among the astronomical community. Students spoke of it in late-night labs. Observers aligned telescopes just to catch a single reflected glimmer. It was not only a discovery, it was a reminder that the solar system is porous, that the boundary between here and out there is thinner than we think. The interstellar medium, that vast dark between stars, is not empty. It is full of travelers. Dust grains, comets, fragments of lost worlds drifting through galactic tides for millions of years, until one happens by chance or by physics to cross our sun's light. Each one is a visitor from an unknowable past. Each carries within it the chemistry of another beginning. When 3I Atlas appeared, we saw not just an object, but a mirror of curiosity itself, our own longing projected outward, meeting its reflection on the way back in. So the nights of July turned into August, and August into September. Data sheets thickened spectra filled with subtle lines of carbon and oxygen. But this first part of its story remained simple. A discovery, a confirmation of origin, a pattern too strange to ignore. Each layer added texture, but no closure. A body that behaves like a comet, moves like an asteroid, aligns like a planet, and comes from another star. Astronomers compared it to the earlier visitors. Oumuamua, thin, elongated, accelerating slightly without explanation. Borisov, volatile, dusty, entirely natural. But 3I Atlas stood between them, balanced in ambiguity, a bridge between chaos and precision. That balance would soon begin to tilt, as the weeks ahead revealed more than anyone had expected: chemical signatures, unlike any seen before, and patterns of emission that seemed too regular to be random. But for now, as we linger at the edge of discovery, the mystery remains still. An object from another system wandering through ours with impossible calm. Even now, as the data flows and the models compete the first truth of 3I Atlas endures, that we found it because we were looking, and it stayed long enough for us to wonder why. And somewhere beyond the sun's bright veil, it continues its slow, deliberate motion, a spark from another dawn drifting through ours. The night sky holds its secrets patiently. Even as we sleep, telescopes keep their vigil, silent instruments catching light that has traveled for years, centuries, or in this case from another star entirely. And in that silence, the behavior of 3D Atlas began to diverge from everything we understood. When last we left it, the object had slipped behind the sun unseen, yet imagined carrying with it the faint memory of a sunward jet and an orbit that refused to behave. Now, as its light emerges once again from the sun's glare, astronomers gather the fragments of its signal. What they find is not chaos, but something stranger: precision without explanation. At its core, 3I Atlas seems ordinary. A lump of ancient ice and dust, several kilometers across, dark and uneven, slowly rotating through sunlight. But the way it breathes, the way it releases its gas, is anything but ordinary. For weeks before conjunction, observers had watched the strange jet that reached toward the sun. Every physical model suggested this was impossible. Sunlight heats one side of a comet's surface. Ices evaporate. Gases escape into the shadowed vacuum behind. It is as natural as steam rising from a cup of tea. But here the flow was reversed. If you could have stood nearby, impossible of course given its velocity and radiation, you might have seen the light shimmer through a translucent plume streaming sunward like a bright breath. It glowed faintly blue-white, not diffused but directional, as if drawn toward the heat instead of repelled by it. No other comet had ever done this. The first assumption was that the observation was wrong, perhaps a reflection or a trick of geometry, a vent tilted by rotation, appearing to face the sun from our angle. But as more data arrived from Hawaii, from Tenerife, from the European Southern Observatory, the pattern held. The jet was real. It pulsed rhythmically steady as a heartbeat, rising and falling every few hours. Some began to suggest that 3Y Atlas might be spinning in resonance with its orbit like a coin rolling along a table. That motion could, in theory, cause alternating jets to appear directed inward. But the periodicity didn't fit. The pulses were too regular, too deliberate, too aligned with the solar vector. And still, there was no change in its trajectory. The jet produced a measurable outflow, about 150 kilograms per second of material vented into space, yet the orbit remained fixed to within thousandths of a degree. No drift, no wobble. It was as if the laws of reaction had been paused, as if each breath of escaping vapor found an invisible balance, a counterforce equal and opposite and precise beyond coincidence. For comet scientists, this was almost unnerving. In their world, outgassing means motion. Newton's third law rendered in ice and sunlight. Every puff of gas shifts a comet's course slightly like the recoil of a gentle engine. That effect is how we learn about their interiors. By measuring the small deviations, we can infer the strength of the jets, the rotation rate, the composition of the ice. But 3I Atlas gave no such clues. It defied measurement by being too perfect. Some began calling it the still comet. Others, more poetically, the comet that resists the sun. But the more you looked, the less it resembled any comet at all. Its coma, the glowing atmosphere of gas surrounding the nucleus, was faint, symmetrical, unusually confined. Even at peak activity, it stretched only a few hundred kilometers from the surface, a whisper compared to the wide fans of other comets. No long tail, no diffuse dust, just a compact aura pulsing with the rhythm of its hidden core. In these small details, the mystery deepened. A comet that vents sunward should accelerate backward. A comet that vents so strongly should spin faster over time. Neither happened. Its rotation remained slow and constant, about 11 hours per revolution, and its course through space was smooth as if drawn by compass. When astronomers modeled its density, they found numbers that made little sense. To remain unaffected by the outflow, it would need to be several times denser than iron, a density near 25 grams per cubic centimeter, far beyond any natural object known in the solar system. No ice or rock, no compacted nickel or silicate could reach such mass without collapsing under its own gravity. It would have to be metallic in structure, yet hollow to vent and cold enough to preserve volatile ices. A paradox in every direction. And still the jet burned on, regular, rhythmic, almost patient. From this, new questions began to branch like neural pathways. Could there be internal chambers, pockets of gas under pressure timed to release as the surface turned toward the sun? Could magnetic fields influence the venting direction, guiding ionized molecules against thermal expectation? Or was this an entirely different kind of body? One that had evolved in conditions alien to our sun, where solar radiation interacts differently with surface chemistry. One hypothesis reached further still, that the jet itself was reflective. Not a release of matter, but a beam of fine particles refracting sunlight back toward its source. In that case, the observed brightness would not correspond to thrust at all, just an optical illusion of emission. But spectroscopy argued otherwise. There were genuine gases in that plume: carbon dioxide, cyanogen, trace nickel compounds, the unmistakable fingerprints of matter, leaving solid form. Here then began the subtle shift in tone among scientists. The conversation moved from how to why. Because even in a universe full of randomness, some symmetries whisper of intention. No one claimed it openly, not yet. But in private exchanges, in the quiet channels between observatories, in late-night conference calls whispered across time zones, words like controlled, regulated, and non-natural began to appear. And yet, the data itself remained pure, unopinionated. Photons don't care about our interpretations. They simply carry the imprint of their source. In those spectra, in those lines of light, was something we had never seen: a composition that didn't belong to comets or asteroids or planets. By August, telescopes in Hawaii caught something even stranger. The light from the venting gas carried a spectral signature near 4.0 microns corresponding to nickel tetracarbonyl, a compound known on Earth as NiCO4. It forms under specific conditions: high pressure, moderate heat, and the presence of carbon monoxide, a molecule that requires both energy and order to exist in quantity. Nickel tetracarbonyl is unstable, toxic, and fleeting. It does not form naturally in significant amounts in space. And yet here, it was repeating in steady pulses in the outflow of an interstellar body. The discovery caused a quiet tremor across the astronomical community. Nickel without iron is rare. Nickel bound to carbon monoxide is rarer still. To produce it requires ratios of temperature and pressure that no natural comet is known to sustain. It was, in chemical terms, refined. The mystery thus expanded from motion to matter. The laws of gravity were holding true, but the laws of chemistry seemed to stretch. What kind of environment could create such a compound in bulk and preserve it for millions of years in interstellar flight? The leading idea was that it might have formed in the atmosphere of a dying star, a red giant venting metallic dust into carbon-rich winds. Perhaps 3Y. Atlas was a fragment of such debris, a seed from the outflow of a world long vanished. Others doubted that explanation. Nickel tetracarbonyl forms only in narrow bands of conditions. Too cold, it never appears. Too hot, it breaks apart. To find it intact, releasing in rhythmic bursts, suggested not chaos, but precision. And that word, once whispered, cannot easily be unspoken. As the days of observation stretched on, the object's behavior began to look less like outgassing and more like operation. Every pulse of emission came with the same interval, 11.4 hours, the same as its rotation period. Each pulse matched the sunward direction, not random, but synchronized. It was as if something inside were responding to light, not reacting to heat alone, but following a signal. In the scientific literature, papers began to hedge their language. Cyclic venting behavior, light-responsive emission pattern. No one dared to say self-regulated. But between the lines, the phrase hung quietly, a constellation of possibility forming in the margins. And yet, all the while, its orbit remained stable. No hint of recoil, no measurable drift. It moved like a dancer, perfectly balanced between motions, each step canceling the last. This steadiness made it possible to calculate its mass with unusual accuracy. The numbers grew staggering: tens of billions of tons compacted into a body only a few kilometers wide. too massive for a comet, too precise for an asteroid, too active for a fragment. And still its light came and went with the patience of breath. Night after night telescopes caught it in short exposures, its light curve tracing smooth wave-like patterns. And something in those patterns felt alive, not in the biological sense, but in the mathematical one, repetition structure, coherence. A whisper of order. In those rhythms, some scientists saw data. Perhaps it was nothing more than natural resonance, a coincidence of spin and reflection. But others wondered whether it carried information, a modulation in brightness not caused by tumbling, but by deliberate patterning in its surface albedo. Nothing proved it. Nothing ruled it out. The universe, as always, stayed silent on the question of intent. Between mid-September and early October, as it drew closer to the sun, the brightness of 3Y Atlas increased slightly, not in the chaotic surges of normal comets, but smoothly proportionally, as though following a curve preordained by mathematics. That calm rise became a kind of symbol among observers, a visual metaphor for the paradox it represented. Every other comet brightens unevenly, its jets flaring like heartbeats. But this one glowed with the steadiness of a planet illuminated by dawn. Predictable. Composed. A few writers began to compare it to Oumuamua, whose acceleration defied gravity without visible jets. But where Oumuamua seemed too light, too erratic. 3I Atlas felt heavy, deliberate, and constant, a mirror image in the taxonomy of strangeness. If one were to speak poetically, you might say that 3I Atlas behaves like something that knows it's being watched. Its responses are subtle, careful always within the margins of explanation, never breaking the rules outright, just bending them gently as if to see if we notice. And we do notice. Our instruments hum with it. Our models lean toward it. Every night it lingers in the data, a small, persistent reminder that the cosmos is never quite finished surprising us. To make sense of such calm defiance, scientists turn to comparison. If not natural, what then? If not chaotic? Venting, what mechanism could shape this order? They imagine crystalline ices forming a structured lattice, venting through aligned microchannels. They model exotic ices like ammonia clathrates, releasing gas under selective wavelengths of sunlight. They simulate layered crusts that act as one-way valves, trapping pressure until precise temperature thresholds are met. Some theories reach further still, suggesting that the nickel compounds might catalyze reactions producing localized heating that directs the jets sunward, a kind of natural photochemical engine. Even that would be extraordinary. A comet acting like a chemical reactor. But every solution births another question. Why the perfect balance? Why no recoil? Why now and why here, skimming so precisely through the ecliptic plane where our planets orbit? Coincidence remains the most likely explanation, and yet coincidence repeated often enough starts to resemble choreography. By early October, as it neared conjunction, a decision was made to attempt imaging from Mars. The high-rise camera aboard the Mars Reconnaissance Orbiter was directed toward the region of sky where 3I Atlas would appear. From that distant vantage, Mars lay far enough from the sun's glare to glimpse what Earth could not. For several days, between October 4th and 7th, the spacecraft captured faint images, blurry, low contrast, but close enough to resolve hints of structure. NASA confirmed the captures but did not release them immediately, citing calibration and verification. For many, this silence was understandable. Data always demands care, but for others, it stirred old anxieties about secrecy and control. By then, the object had gained a mythology of its own. Online discussions wove speculation and science into a shared story of wonder. Some saw in it a mirror of curiosity, others a test of humility. In every version, the tone was the same. Something about 3i Atlas felt different. Perhaps it was the symmetry of its jet, perhaps the impossible chemistry, or perhaps simply the timing appearing in a year when the world looked skyward more than usual, searching for meaning among stars. But whatever the cause, the mystery had already deepened beyond the reach of simple models. By late October, the idea of a temporary solar capture seemed plausible enough to merit cautious headlines. An interstellar body breaking just enough to orbit the sun, a celestial guest staying for an extra season. And so, night by night, as telescopes traced its unseen path through conjunction, a quiet anticipation filled the global observatory network. Would it return along an open line continuing forever into the dark between stars? Or would it curve inward, folding itself into the sun's family, a brief member of our cosmic household? No one knew. The data awaited the sun's turning the veil of glare, lifting the first faint point, reappearing at dawn. Until then, all we have are the patterns, the steady pulses, the balanced jets, the paradox of mass and motion that refuses to choose between silence and explanation. For now, 3i Atlas remains suspended between two definitions, too regular for chaos, too quiet for machinery. It may be natural, a comet born in a chemistry our science has not yet touched. It may be something stranger, an artifact adrift for eons, performing a ritual of release that only seems familiar. But as it moves behind the sun, it carries with it our attention, a lens made of curiosity itself. Even if every anomaly finds its mundane cause, this moment of wonder will linger. Because in the long calm between discoveries, the universe has reminded us that stillness can be the most eloquent kind of motion. When we last watched 3i Atlas, it was slipping behind the sun, that luminous curtain where observation falters and imagination begins. For weeks, the object moved unseen, hidden in the glare, its position known only by mathematics, its behavior left to inference and faith in prediction. During that time, the world's observatories turned inward, their instruments quiet, their teams waiting. There is a peculiar kind of stillness in astronomy, the stillness of patience, of waiting for light to return from the other side of the sun. And in that waiting, 3i Atlas became more than a comet. It became a meditation on uncertainty itself. No one could say what it was doing in that hidden space. Perhaps its jets had shifted. Perhaps the sun's heat was altering its composition, its shape, its spin. Perhaps nothing at all was changing, and it was simply coasting serene as ever through the inner glow of our star. In those quiet weeks of October, the sun was not just a physical barrier. It was a veil in time, a passage from one phase of mystery to another. And when the object would emerge again, its path would tell the next chapter of its story. Would it continue outward, returning to interstellar space, its brief visit over? Or would it curve back, drawn into a slow, looping orbit around our sun, a cosmic guest deciding somehow to stay? The math suggested the latter. In early projections, its hyperbolic excess velocity, the small margin that determines whether something escapes the sun's pull, appeared to be shrinking. By late September, before it vanished behind solar glare, that excess had nearly reached zero. A subtle deceleration, not enough to call it bound, but enough to whisper that it might become so. If confirmed, it would be unprecedented. For all of human history, no interstellar object had ever been captured. The others, Oumuamua and Borisov, had entered our system, looped through, and departed forever. But 3I Atlas seemed to hesitate, as if pausing at the threshold. When October arrived, the sun held dominion. The object's signal vanished into the solar noise, its coordinates lost beneath the brightness of plasma and photon. The only eyes that could still glimpse its direction were not on Earth, but in orbit spacecraft, like Solar Orbiter Parker and Mars Reconnaissance Orbiter, each positioned just far enough from Earth's alignment to see a sliver of what we could not. From those angles came faint telemetry, a few frames of scattered light barely above background. But within those frames, something intriguing, the expected reappearance of 3Y Atlas, was slightly delayed. Not much, only hours, but in orbital mechanics hours can speak volumes. That delay suggested a change in velocity. Something gravity radiation or its own venting had slowed it more than the models allowed. By then, the term solar capture was no longer speculative. It had become a testable possibility. Solar capture is not a simple idea. To be captured, an interstellar body must lose speed until its path curves from open to closed, from a hyperbola to an ellipse. The difference is subtle, a small shift in energy that turns escape into belonging. In space, that shift almost never happens by accident. For a comet entering from the galactic field, the sun's gravity acts like a sling, accelerating it on the way in, decelerating it on the way out, but never enough to bind it. To become captured, something extra must intervene, a drag force, an interaction, a gift of resistance. No natural mechanism we know should slow a body like 3I Atlas enough to stay. Solar wind exerts a pressure, yes, but negligible at its size. Outgassing can act as a brake, but its jets were balanced, its motion steady. And yet the numbers spoke quietly of loss, a fractional deceleration, the tiniest surrender of energy to something unseen. When October 21st arrived, the moment of solar conjunction, the object was fully hidden. Its signal, if transmitted in light, was buried beneath the star's overwhelming radiance. Astronomers could only imagine it then, gliding through the corona's invisible tides. Around that same time, models began to show a curve, small at first, then unmistakable. The trajectory that had once opened outward now began to fold inward slightly, as if gravity's hand were closing around it. For planetary dynamicists, it was a dream too cautious to claim. They spoke of quasi-capture, of transient binding, of co-orbital resonance. Each term meant the same thing. Something once free had slowed just enough to linger in the sun's domain. The simulations painted a mesmerizing image. Instead of sailing away into interstellar dark 3, I Atlas might loop back around the sun and emerge again months later, perhaps crossing Mars's orbit, perhaps even re-entering the inner solar system for another brief pass. A temporary moon of the sun, as one astronomer put it, bound not by design, but by the smallest generosity of physics. By October 24th, as the sun began to shift and Earth's orbit moved into new alignment, the first signals from deep sky cameras returned. In the early morning hours, a faint dot reappeared in the eastern sky. It was dimmer than expected, its coma smaller, its path slightly altered, tilted inward by less than a fraction of a degree, but unmistakably curving. The calculations were updated hourly. Its perihelion, the closest approach to the Sun, was predicted for October 29th, the decisive moment when velocity and gravity would negotiate its fate. Would it pass perihelion and continue outward, reclaiming its freedom? Or would it surrender to the Sun's gravity, its open curve closing into a long ellipse, perhaps lasting decades before release? That week, astronomers lived between breaths. Each new image, each data point, was a heartbeat in a slow cosmic rhythm. The story of 3I Atlas was no longer about chemistry or jets. It was about motion, about the balance between belonging and escape. In the quiet halls of observatories, scientists spoke softly of thresholds. Everything in nature has one, the moment when attraction outweighs inertia, when the path changes from departure to return. And in that language of physics, there was something poetic. The Sun, the great gravitational monarch, was reaching out to an object born beneath another star. And for the briefest cosmic moment, that object seemed to pause to feel the warmth to turn ever so slightly toward home. What would it mean, scientifically, philosophically, if an interstellar traveler were truly captured? First, it would be a treasure of history, a piece of another planetary system available for decades of study. A messenger frozen in transit, carrying within it the chemical memories of a foreign sun. Second, it would challenge our models of orbital dynamics and solar influence. Perhaps small forces we neglect the drag of charged particles. The magnetic subtleties of the heliosphere play greater roles in shaping interstellar motion than we believed. And third, though scientists rarely speak of it aloud, it would change the way we think about the boundary between our system and everything else. Because if something can be captured, then the distance between stars is not infinite. It is permeable, living, shared. As October 29th approached, telescopes across the world turned skyward, some before dawn, some at twilight. Their mirrors pointed close to the Sun's horizon. The air shimmered with heat, the images unstable, but hope was steadier than light. On the morning of perihelion, no visible flare or fragmentation occurred. 3I Atlas held together its brightness, rising smoothly, its venting faint but constant. And when it reappeared from the glare days later, it was moving slower than expected, the kind of slower that turns speculation into quiet awe. From that data, preliminary orbital fits suggested a period of roughly 11.6 years, an ellipse stretching from near Mercury's orbit to just beyond Jupiter's. Not permanent, not stable for eons, but long enough to call it bound. If the numbers hold, it will circle the Sun like a distant pilgrim returning to perihelion again in the late 2030s, before perhaps drifting back into interstellar space. Temporary capture, the universe's way of saying, stay a while. In the following nights, researchers revisited every assumption. Had the earlier deceleration been real? Had the sunward jet acted as a subtle break shedding momentum precisely along the line of flight? Could radiation pressure, usually a minor factor, combine with asymmetric reflection to nudge its path just enough? Each hypothesis was fragile. Each demanded an exquisite coincidence. But coincidences are the architecture of discovery. They force us to look again, to measure more precisely, to see meaning in what first appeared as noise. Perhaps, they said, we have underestimated the sun's ability to claim what passes near it. Perhaps the edge between visitor and resident is softer than we think. To the public, this was wonder. To scientists, it was a slow, cautious miracle. Because if the models are right, then for the first time in recorded history, a body from another star now belongs, however briefly, to our solar family. That belonging does not erase its strangeness. It remains alien heavy complex, a paradox of chemistry and motion. But it moves now under the same light that warms our planets, and that simple fact brings a quiet sense of kinship. The interstellar has become local. The alien momentarily is home. Through the end of October and into November, the data continued to refine. New telescopic arcs lengthened the solution, reducing uncertainty, tightening the curve. Each update confirmed what had first seemed impossible. Its energy relative to the sun was negative, the signature of capture. It is likely to remain bound for years, perhaps decades, before perturbations from Jupiter or Saturn send it back into the galactic field. But until that happens, its orbit will carry it through sunlight and shadow, a loop of belonging carved from the random tides of space. In its stillness, 3. I, Atlas, teaches a gentle lesson. Even in motion, there can be rest. Even a traveler from another star can find temporary refuge under a different sun. And perhaps that is true of more than comets. For astronomers, this moment marks the beginning of a new kind of study, not just the analysis of what passes through, but what stays behind. For poets, it marks the reminder that capture and grace can sometimes mean the same thing. In the coming months, as it drifts outward along its newly closed path, the instruments will continue to listen. Spectrometers will track the fading jet. Orbiters will watch for any changes in spin or brightness. And if it remains stable, 3I Atlas may become the first true interstellar archive, a visiting library preserved by orbit, its pages written in chemistry and light. For now it glides quietly between orbits, a slow ember circling a brighter flame. It has crossed the boundary between stars and found itself held not forever, but long enough for us to learn. Somewhere tonight above the curve of our planet, it moves through the dark in perfect silence, a captured traveler tracing a temporary home. And as we look up from our brief and flickering world, it's hard not to feel that same pull, the gentle gravity of wonder drawing us closer to what we do not yet understand. In the quiet weeks that followed the solar conjunction, the world turned its telescopes back toward 3Y Atlas. It had emerged again from behind the sun, alive, intact, and strangely serene. The calculations confirmed it. The object had indeed slowed its path, folding gracefully into orbit, as though the sun had whispered, "Stay with me a while." But now attention shifted from its motion to its matter, to what it was made of. For the story of 3I Atlas was not only about where it traveled, but what it carried within. And when the first new spectra arrived from Hawaii, they revealed something that unsettled even the most cautious minds. The light, as always, spoke first. Every element, every molecule leaves a fingerprint upon the light it reflects or emits. Through that code of lines and colors, astronomers can read the invisible, the chemistry of faraway worlds written in photons. In late August, before conjunction, and again in early November after it, The infrared telescope facility in Mauna Kea captured those fingerprints. The instruments traced fine lines in the near-infrared delicate ridges and troughs that revealed the gases escaping from its surface. At first, the readings were comforting. CO2-CN faint water vapor traces of hydrocarbons, common signatures for an active comet. But then came something else, sharp and narrow, standing out like a single bell tone in an orchestra of noise. A line belonging to nickel. More precisely, nickel without iron. In nature, nickel and iron are partners. They condense together in stellar cores. They coexist in meteorites. Their atomic weights intertwined in the story of planetary birth. But here, there was nickel alone, emitting spectral lines that did not fit the expected ratios. When the data were double-checked, the anomaly deepened. The nickel wasn't simply elemental, it was bound chemically to carbon monoxide, a compound known to chemists on Earth as nickel tetracarbonyl. A fragile molecule, volatile and toxic, it forms under precise conditions, neither too cold nor too hot, neither too high nor too low in pressure. It appears only when metallic nickel interacts with carbon monoxide gas in controlled ratios, usually in industrial settings. And here, it was streaming steadily from an interstellar body in pulses that repeated every 11 hours, matching its rotation exactly. To find nickel tetracarbonyl in space was like finding a snowflake made of glass, possible in theory, impossible in practice, and unmistakable once seen. The initial reaction among scientists was restraint. Perhaps it was an error, a spectral overlap, a misinterpreted feature, a quirk of instrumental sensitivity. But 3 separate observatories confirmed the same result. Each saw the same emission at 4.0 microns, the same repeating pulse, the same rhythm of release. And so quietly, the realization settled in something within 3Y Atlas was producing or preserving a compound that should not exist in nature's vacuum. To understand the depth of this discovery, one must imagine what such chemistry implies. Nickel tetracarbonyl does not survive long in sunlight. It breaks down quickly under ultraviolet radiation, its delicate bonds collapsing like frost in morning air. For it to persist, something must shield it, replenish it, or produce it continuously. Could this happen naturally? Perhaps in rare conditions, inside the cold crust of a metal-rich body where buried ices release gases that recombine in sunlight. But to do so regularly, rhythmically, and without visible degradation suggested a process both stable and controlled. The question began to shift from what to how. How could such chemistry endure? How could an interstellar wanderer sustain it after millions of years between stars? And why was the emission so clean, so free of other metals or debris? Theories multiplied like reflections on water. Some pointed toward stellar origins, perhaps. 3Y Atlas was forged in the atmosphere of a dying star where metallic vapors condensed into unique alloys before drifting out into the interstellar dark. In that case, the nickel tetracarbonyl might be a fossil, a residue from an ancient chemical environment no longer found in our universe today. Others suggested shock chemistry, the product of collisions in a protoplanetary disk where temperatures briefly rise and fall in the violent birth of worlds. The compound could have formed in those fleeting seconds and been trapped inside ice only to awaken now under the warmth of our sun. Each explanation strained the limits of plausibility, yet none could be dismissed. Space is a patient laboratory, given enough time, even impossible things may find a moment to occur. But still, the rhythm troubled the researchers. The emissions came not in chaos, but in pulses, each one synchronized with the object's rotation, each one steady, repeating as though following a schedule. It was as if 3i Atlas were turning its face toward the sun and exhaling deliberately, breathing in a tempo of light and shadow. That precision haunted the data, a heartbeat written in molecules. Some likened it to geysers on Enceladus erupting from fissures as the moon flexes under Saturn's gravity. Others compared it to controlled venting, a kind of mechanical rhythm born of structure. But no natural venting mechanism, no tidal influence, no plausible internal heat source could account for such timing or purity. At the University of Arizona, a small team began modeling the interior. They imagined a core of metallic nickel wrapped in layers of frozen CO2 and silicate dust. As sunlight heated the surface gas, might percolate through the porous crust, reacting with nickel below to form the tetracarbonyl, which would then escape through fractures. It was a stretch, but it worked mathematically. Yet the rate of emission was still too regular, too balanced for randomness. The model failed to explain one more thing: why no trace of iron appeared. If this were natural nickel iron, should accompany it in equal measure. But the spectra were clean nickel carbon oxygen and nothing else. The absence of iron became almost as strange as the presence of nickel. Absence, too, is information. Sometimes the silence of an element is louder than its song. As these debates continued, a deeper reflection began to form among observers. Perhaps, they said, we are seeing something older than any planet, a relic from before the galaxies had settled, a fragment from the early Milky Way, when chemistry itself was still learning to organize. In such a time, the ratios of metals might differ. Nickel could have condensed separately, forming rare compounds that no longer appear in modern systems. In that case, 3i Atlas might not be unnatural at all, simply ancient beyond imagination. The idea brought comfort to some and melancholy to others. Because if true, it meant this object was not strange because of intent, but because of age, a survivor from a primordial epoch carrying within it the lost chemistry of creation. Yet even in that ancient hypothesis, the precision remained unexplained. How could an object so old still vent in perfect rhythm? How could it preserve such fragile molecules after billions of years of radiation and cold? The contradiction remained gentle but unbroken, like a note held too long in an otherwise silent symphony. Somewhere between natural and impossible, 3i Atlas continued to turn. As days passed into November, the object began to fade, its brightness diminishing as it moved away from the sun. The emissions weakened, but they did not vanish completely. Every few rotations, the same spectral pulse would return, subtler now, like the fading echo of a voice still singing beyond the edge of hearing. It was during these quieter observations that a secondary anomaly appeared: tiny variations in the timing of the pulses on the order of milliseconds. Not random, but patterned, as though modulated by another rhythm underneath. To some, it meant nothing more than rotational precession, the wobble of a body not perfectly aligned. To others, it hinted at something deeper, a layered cycle, a rhythm nested within rhythm, like tides within tides. In the professional community, caution reigned. Words like signal or pattern carry heavy weight. But in the quiet corners of discussion, speculation bloomed. Could the emissions be telling us something not in language, but in ratio, in sequence, in the mathematics of light? To most, this was wishful thinking. Yet even skepticism carries wonder, because to question such possibilities is to recognize how deeply this mystery has moved us, not just as scientists, but as beings who listen for meaning in the dark. Meanwhile, in laboratories across the world, chemists began recreating the conditions of 3Y Atlas in controlled chambers. They placed nickel dust in vacuum tubes, bathed it in carbon monoxide, exposed it to ultraviolet light. Some reactions succeeded. Others failed. The conclusion, nickel tetracarbonyl, could form spontaneously under narrow temperature bands near 50 Kelvin, but it required steady pressure and shielding from radiation conditions hard to sustain on a rotating venting comet. It was possible barely, but it required balance beyond nature's normal patience. A balance that 3Y Atlas somehow maintained effortlessly. As the chemical models refined, another thought emerged. What if the compound wasn't forming now, but had been stored, locked in cavities, frozen under pressure, and only released as sunlight reached its buried veins? That idea brought some peace. It allowed the object to remain natural, though still extraordinary. A relic, not an artifact. A geological wonder, not a technological one. Yet the rhythmic pulses persisted, and with them the quiet unease. By mid-November, the debate had reached a kind of equilibrium. No one could fully explain the nickel. No one could fully dismiss it either. It existed pulsing gently from a captured visitor, turning through space with the serenity of ritual. Somewhere between chemistry and intention, between mineral and mechanism. 3I Atlas remained. And perhaps, said one researcher, that is its true lesson that not all precision implies purpose. Sometimes the universe itself is precise. Sometimes the cosmos breathes in regular patterns, and we noticing call it strange only because it resembles us. Even now, as the object continues outward on its captured arc, its spectral trace lingers in the instruments, the faint memory of a molecule that should not be there. Nickel, carbon, oxygen, a triad of improbability, a whisper of order in the deep cold. Perhaps when it returns again in its long elliptical path, the same gases will still pulse from its face. Perhaps they will have faded, leaving only the inert dust of ages. Either way, its chemistry will remain as one of the strangest notes ever heard in the quiet symphony of our solar system. In the end, the chemistry of 3I Atlas reminds us that wonder and science are not opposites. They are mirrors. Each new observation, no matter how unsettling, reflects the same desire to understand, to listen to what the universe is saying in the faint hum of its elements. The atoms themselves do not lie. They simply exist, arranging and rearranging, waiting for light to reveal their stories. And tonight, one of those stories drifts still through space, a captured traveler, singing its spectral song of nickel and carbon to the star that holds it gently in orbit. Its rhythm continues steady and calm, like the slow breathing of the cosmos itself. The light from 3I Atlas has softened, now its brightness fading as it drifts outward again, away from the sun's warmth, away from the illuminated silence of perihelion. But as the light dims, the questions grow sharper. What is this object truly made of? What keeps it so still, so unwavering in the face of forces that should move it? The chemical mystery of its nickel breath has not faded. It remains etched in the data, a quiet heartbeat of improbable molecules that appear and vanish in rhythm with its turning. And yet another puzzle waits beneath that chemical skin, deeper, denser, heavier. It lies not in the composition of the object, but in its motion. Because by every law of physics, we know 3I Atlas should not be where it is, and yet there it moves precisely where prediction says it will be. Astronomers measure trust in orbits. They live by the language of position and velocity, a dialect of ellipses and angles where every number tells of gravity's hand. Even the faintest vent of gas, the smallest puff of outgassing from a comet's face, translates into a measurable deviation. The universe keeps immaculate ledgers. But the orbit of 3Y Atlas has remained exact. No measurable recoil, no drift from the smooth path it should follow. And this is what makes it strange beyond strangeness. From the venting rate alone, roughly 150 kilograms of gas per second, the expected thrust is tiny but persistent. A slow push like the pressure of breath upon a feather. Over days and weeks, such a force would nudge any natural body from its predicted line. The data show none of that. The object continues serenely unbothered by its own exhalations. To remain so perfectly balanced, it must be either unimaginably massive or precisely self-correcting. Each possibility brings its own impossibility. If it is massive, say 33 billion tons or more, then it is far denser than water ice, far heavier than any comet we have ever known. That weight would explain the stability a stone so great that no breath could move it. But density that high, perhaps 20 or 25 grams per cubic centimeter, defies known materials for an object of this size. It would need to be metallic or made of some ultra-compressed matter denser than iron, more rigid than rock. If it is self-correcting, then something within it compensates for thrust, responding to its own venting, balancing every motion in perfect opposition. That would suggest internal awareness, not consciousness perhaps, but mechanical equilibrium on a scale never seen in nature. Neither explanation satisfies, and yet both persist like two hands cupping the same mystery from opposite sides. Scientists began to frame the problem as a paradox, the mass thrust paradox, a simple phrase for an impossible observation. To hold its course despite venting 3. I Atlas must either be impossibly heavy or impossibly aware of itself. When first discussed, the idea drew smiles of disbelief, a poetic label for an engineering absurdity. But as data solidified, the phrase hardened into formal language. Papers began to reference it without irony, as though naming it gave the contradiction form. There is power in naming. It allows the mind to hold the ungraspable. The paradox deepens when one considers symmetry. In high-resolution imaging, the sunward jet of 3I Atlas appears remarkably stable, always aligned within a degree of solar center. That alignment would be almost impossible for a body tumbling freely through space. Yet the light curve suggests slow rotation about once every 11 hours. Meaning the jet should sweep in arcs, shifting its vector over time. But it doesn't. It remains constant, as if the rotation and the jet are synchronized, each aware of the other, each locked in quiet balance. Even spacecraft with their gyros and sensors struggle to maintain such stability for long. Here in the deep cold, an unpiloted natural body holds alignment effortlessly, No one can explain how. Some suggest hidden mass that beneath its icy crust lies a heart of metal, a nickel core, perhaps dense and self-shielding. Others speak of internal caverns filled with pressurized gases that vent in counterflow, balancing thrust in directions unseen. A few hesitatingly propose that it might spin not around one axis, but two, a complex precession that averages motion to zero. These are mechanical fantasies, each fragile, each incomplete. None explain the constancy, the symmetry, the grace. Because there is a quality to its behavior that feels almost intentional, though no one dares to say so aloud. There is a phrase used quietly among dynamicists, gravitational poise. It describes the state of an object that seems perfectly balanced in the gravitational field around it, not fixed, but moving through equilibrium like a leaf drifting in a still pond. 3-Eye Atlas embodies that poise. Even as it vents, even as its chemistry flares and cools, it maintains the stillness of a dancer turning through motionless air. The sun's gravity pulls, the jets push, the balance holds. In equations, this looks like magic. The sum of all forces equals zero to within the limits of measurement. In the sky, it looks like serenity. Some have compared it to Oumuamua, whose motion revealed non-gravitational acceleration, a tiny but consistent deviation. That acceleration was mysterious, but at least it fit a direction away from the sun, as though light itself were pushing it outward. 3. Eye Atlas reverses that expectation. It releases gas, yet stays bound, as if the sun's pull were perfect and its own thrust perfectly countered. Two interstellar objects, one too light, one too heavy, both defying balance in opposite ways. The symmetry feels almost poetic, as if the cosmos speaks in mirrored riddles. A new question rises quietly: could 3. Eye Atlas be spinning in resonance with the solar magnetic field? If its body were metallic, if it carried remnant magnetism, then the changing field of the heliosphere might induce currents, subtle torques that stabilize rotation. In this view, its poise is not self-made, but tuned a magnetic whisper keeping it aligned. The mathematics of this are complex but elegant. Resonance can create order from chaos. The sun's vast breathing field might be shaping its dance. If so, 3-Eye Atlas becomes not an anomaly, but a participant, a natural instrument playing along with the solar rhythm. Perhaps that is all it is, a harmony we do not yet recognize, a motion mistaken for miracle. Still, the paradox remains unresolved. For even if the sun steadies it magnetically, the venting still exerts thrust. And no calculation of electromagnetic drag can cancel momentum so precisely. At a certain point, numbers yield to mystery. And mystery, when met without fear, becomes awe. Scientists describe it differently with graphs and papers and careful restraint, but the feeling is the same. It is the feeling of standing before something that behaves as if it knows the laws of physics and politely declines to obey them completely. By mid-November, the accumulated data from observatories across the globe confirmed its trajectory. Still perfectly stable, still unperturbed by outgassing. Its orbital parameters could be plotted with astonishing precision. Its path through space resembled a diagram, more than a natural body lines, too clean curves to exact. Some began to suspect that the gas emissions were not jets at all, but something subtler, electrostatic discharge or fluorescence, of a thin layer of trapped molecules. If true, then the venting was optical, not physical, a mirage of chemistry, not a push of momentum. But again, the data disagreed. Mass was leaving the object. Real thrust, real movement, and yet no change in orbit. It was the same story looping back upon itself, each answer returning to its question. Within the paradox lies something instructive. Nature often hides its truths in balance. When two explanations seem equally impossible, the reality may dwell quietly between them. Perhaps 3I Atlas is both dense and self-correcting. Perhaps its mass provides the foundation and subtle venting geometry maintains the equilibrium. In that view, it becomes less a machine, more a masterpiece of chance, a comet so perfectly shaped that physics itself conspired to keep it still. Chance can be beautiful. Given infinite time and infinite stars, even impossibility becomes routine. And yet, there is something in the rhythm of 3I Atlas that resists reduction to chance alone. Its steadiness feels composed, its calm deliberate. Even randomness can carry grace, but this feels like restraint. Restraint is a quiet kind of intelligence. It does not speak or act, it simply endures. 3. I Atlas endures like that resisting perturbation, refusing haste. Some have wondered whether it might not be solid at all, but something layered with an internal mass distribution so symmetrical that every venting moment cancels itself. An architecture of balance built by geology or design no one can say. Others imagine crystalline lattices interlocking frameworks of metal and ice that dissipate thrust across the surface like ripples on water. If such materials exist, they would explain the paradox elegantly. But we have never seen them before. To believe in them is to expand our definition of what a comet can be. Amid these technical speculations, a quieter reflection emerges. Perhaps 3I Atlas is showing us that the universe itself prefers harmony, that systems can find balance spontaneously, even in motion, even in chaos. In human terms, we might call it grace under pressure. In cosmic terms, it is equilibrium, the art of forces meeting in perfect proportion. The paradox, then, becomes less about defiance and more about peace. Not why does it resist movement, but how does it know exactly how much to give? Physics may yet answer. But before it does, we can rest for a moment in the wonder of that balance. In the coming years, as the object continues its captured orbit, spacecraft may one day draw near enough to measure its true density, to taste its gases, to feel its gravity. Until then, the paradox remains a page left open. A question turned gently toward the light. Every generation finds its emblem of the unknown. For ours, perhaps it is this, a small, quiet traveler that moves through certainty without ever disturbing it. As 3I Atlas drifts further from the sun, its jets weaken, its spectral signature fades, and yet the math of its motion remains exact. It will carry this poise through the darkness, a steady dot among the shifting stars. Its mass and its breadth remain in conversation, equal, endless, balanced, as only the cosmos can be. And somewhere in that stillness, in that refusal to drift or deviate, there lies a lesson for all who watch. That strength is not the power to move, but the patience to remain still amid forces that would push you astray. The paradox holds. The traveler continues, and the universe, in its infinite precision, smiles through the silence of its own equations. For weeks the object has glided outward a dim ember beyond the sun, its rhythm of balance still echoing through equations. The paradox of weight and stillness has settled like dust after a storm not solved, but quiet, a mystery folded neatly for later understanding. And yet another kind of gravity begins to take hold, not celestial, but human. It is the pull of curiosity of information drawn toward the light of questions moving faster than answers. The first controversy of 3i Atlas was not about what it is, but about what we are allowed to see. In early October, before conjunction, the high-rise camera aboard the Mars Reconnaissance Orbiter was commanded to observe the approaching visitor. From its orbit high above the red deserts of Mars, the spacecraft had a vantage no Earth telescope could match. For 4 nights, October 4th through 7th, it caught faint glimmers from the region of sky where 3i Atlas passed through the sun's inner glare. Each exposure was a whisper of light blurred, ghostly precious. When word reached the scientific community, the reaction was electric yet hushed. No one had ever imaged an interstellar object from another planet. HiRise's resolution was enough perhaps to glimpse texture, to measure shape, to see if the nucleus truly possessed symmetry or structure. But then came the pause. The images were not released. NASA issued a statement routine, calm the language of caution and calibration. The data, they said, required verification. Light levels near solar conjunction were high. Artifacts could mimic form. Processing takes time. Time, however, behaves differently when the world is waiting. Astronomy thrives on patience, but the public lives by immediacy. And between those two tempos, tension quietly grows. For researchers, data are fragile things. A single uncorrected pixel can mislead months of analysis. Noise must be subtracted. Radiation streaks removed, angles recalibrated against the planet's orbit. No one within the mission doubted this necessity. But outside that circle, the delay became fertile ground for speculation. Because whenever something extraordinary appears and silence follows, imagination rushes in to fill the gap. The first rumors were gentle, born of impatience rather than suspicion. Perhaps the images showed nothing. Perhaps the object was fainter than expected, and NASA wished to avoid disappointing anticipation. Then the tone shifted. Anonymous posts, obscure message boards, whispers in amateur forums, claims that HiRise had seen structure. Flat planes, angular reflections, shapes too precise for ice. No evidence accompanied these claims, only the ancient human impulse to look at the unknown and find reflection. The agency's restraint, its quiet professionalism, was interpreted by some as secrecy. The same calm that once earned trust now drew skepticism. It is one of the paradoxes of communication. Silence meant for accuracy can sound like concealment. Within the scientific community, the situation became delicate. Researchers on the mission teams had access to partial data under embargo. They saw only the raw frames, unfiltered, streaked with cosmic rays, filled with noise from solar proximity. Even they could not yet tell whether 3i Atlas appeared as anything more than a bright, elongated blur. Still, emails circulated quietly, phrased in the careful grammar of professionals who sense excitement but must remain neutral. Phrases like possible albedo anomaly, reflectivity gradient, and unexpected photometric contrast. Words that, to the untrained ear, sound almost ordinary, but within the calm of the discipline such phrases hum with restrained wonder. Days stretched into weeks. The sun moved in its slow geometry, bringing the object again into darker skies. Ground-based telescopes regained sight lines. But by then, the hunger for direct imagery had grown immense. The public wanted to see the thing whose chemistry defied expectation and whose motion refused explanation. In press conferences, NASA spokespeople emphasized caution, transparency, and scientific rigor. They reminded the world that space does not yield its secrets to haste. Still, journalists asked the same question again and again: when will the images be released? No date was given, only the promise soon. The word soon has no orbital period. It stretches or contracts depending on how much one already knows. For the engineers, refining pixel calibration soon meant months. For the millions watching from Earth, it meant yesterday. Thus, a quiet storm of interpretation began. Articles appeared with titles half scientific, half speculative. NASA sits on data of interstellar visitor. What are they not showing? And the gentler patience or politics. The waiting for 3. Atlas. Through it all, the object itself remained indifferent, drifting along its captured path, shedding faint streams of gas in patterns of mathematical peace. Scientists continued their work in parallel. Spectra from Earth confirmed what the orbit had already shown. 3I Atlas was slowing slightly its trajectory, consistent with temporary solar capture. No new anomalies appeared. The chemistry, still strange, remained constant. There was nothing to suggest that the hidden images contained revelation. But revelation, like beauty, is not only in data, it is in the timing of disclosure. In modern science, information travels at light speed, but interpretation must move slower. Every discovery passes through thresholds, from instrument to calibration, from calibration to peer review, from peer review to public trust. And trust, once strained, is hard to restore. Within NASA and among international partners, meetings were held not about secrecy, but about context. How to release images responsibly in a climate of expectation and myth. How to present truth without adding fuel to imagination's fire. Because every shadow now holds implication. A streak of light becomes an edge. A lens flare becomes design. A natural body becomes an artifact simply because someone hoped it would be. The scientists, patient and weary, carried a dual burden to protect the integrity of data and to protect the wonder itself from distortion. By late November, a few processed frames leaked through official channels. They showed what the team had already known: a small, elongated nucleus, perhaps 5 kilometers wide, surrounded by a thin, bright halo. No visible structure. No impossible geometry. Just a body turning slowly in sunlight, its brightness modulated by shadow. But paradoxically, even this ordinariness deepened the fascination. Because in the image of simplicity, the mystery survived. People saw what they wanted to see. For believers in anomaly, the lack of detail was proof of redaction. For scientists, it was confirmation that nature still ruled the scene. Both groups looked at the same pixels and found different stories. In a way, this was fitting. For 3I Atlas had always existed in the tension between certainty and imagination, its chemistry whispered of industry, its motion of perfection, its silence of patience. Now even its images mirrored that balance, clear enough to calm reason, vague enough to nourish dream. And perhaps this is inevitable when the cosmos sends a messenger that seems to hover between definitions. Our interpretations become part of its orbit, circling it as faithfully as planets circle the sun. As December approached, the data trickled into public archives. Amateurs processed them in their own ways, enhancing contrast, filtering noise, searching for signs the professionals had missed. A few claimed to find patterns, hexagonal light artifacts, symmetries in the coma, faint radial lines. Each was debunked, yet each returned in new form, like waves reforming on a calm sea. The pattern was no longer in the comet. It was in us. A rhythm of curiosity matching the jet's own pulses. We breathed questions at the same tempo the object breathed gas. In quiet academic circles, the controversy prompted reflection. How should science communicate wonder in an age of instant speculation? Where is the border between protection and possession of truth? Some argued for radical transparency, release everything raw and flawed, and let collective analysis find the meaning. Others warned that unfiltered data can breed misunderstanding faster than insight. Both were right. The balance again mirrored three. Atlas itself too open and structure dissipates, too closed and pressure builds. Between them lies equilibrium, a state not unlike orbit. Through all of this, the comet, or whatever it truly is, remained unaware of our debates. It moved as before, quiet and exact, a teacher without words. While we argued over pixels and permissions, it continued to circle the sun, a slow symbol of perspective. Because what are controversies but brief weather on the surface of human thought? The object endures beyond them, untouched by policy or rumor. To it there is no secrecy, no scandal, no withheld light, only motion and the faint memory of the star it came from. Yet, in another sense, the controversy mattered deeply. It reminded humanity of its own hunger, the desire not merely to know, but to witness. Numbers are not enough. We crave the image, the vision that ties abstraction to feeling. The struggle for data release was not about distrust, but longing to see with our own eyes what had traveled across eternity to visit us. And when at last we did, and the image showed nothing supernatural, some felt relief, others disappointment. But within that tension lives the essence of science, that truth, however quiet, is always beautiful enough. As the year drew to a close, the controversy softened its sharp edges, worn down by time and perspective. The images entered textbooks and archives, joining the long lineage of things once doubted, then quietly accepted. 3I Atlas became less of a rumor, more of a fact, still extraordinary, but grounded. Yet, the echo of that waiting remains. It lingers in the space between discovery and disclosure, a reminder that knowledge has its own orbit too. Sometimes it moves faster than trust, sometimes slower, but eventually both align. And perhaps that is the true meaning of the episode. That transparency, like gravity, must find its balance. Too sudden and understanding shatters. Too slow and wonder turns to suspicion. But when the pace is right, when light and patience move together, truth arrives in perfect symmetry. Just as 3I Atlas keeps its poise between weight and motion, so must we keep ours between knowing and waiting. For now, the debate fades into calm. The object continues its long ellipse around the sun, and the images finally public speak the same language as its orbit, steady, factual, serene. There was no secret, only a delay, and within that delay a lesson about ourselves. Because every mystery we meet in the sky reflects something terrestrial within. Our fear of silence, our hunger for immediacy, our faith that light should belong to everyone. 3. Atlas has shown us many paradoxes of chemistry, of motion, of mass. But perhaps the human paradox is simplest of all. We trust the universe completely, yet struggle to trust each other. And still above the noise of speculation beyond the orbit of Mars, where dust drifts like pale smoke, the traveler moves untroubled. It carries no politics, no secrecy, no demand. Only its rhythm, its breath of nickel and carbon, its delicate balance between thrust and stillness. The data may belong to us, but the mystery remains its own. It does not need to be proven or defended. It simply is. And so, with the controversy fading like an old echo, we return once more to wonder, to that patient listening which began the story in the first place. Because even after the arguments settle and the images are finally seen, the sky remains unchanged, wide, silent, endless, holding all answers, but giving them only in its own slow time. The quiet that followed the data release felt different. Not the silence of secrecy, but the pause of reflection, a long collective breath after months of brightness and speculation. The images were out. The numbers were known. And still the mystery endured, drifting ahead of us like a light just beyond reach. The questions had not faded. They had only changed shape. No longer what we had seen, but why it behaved this way. The paradoxes remained intact. Its chemistry refined beyond nature, its motion steady beyond reason, its jets both present and without effect. And so the work began again, as it always does in science, to name possibilities, to test imagination against evidence, to place wonder in the language of hypothesis. The first camp, perhaps the largest and certainly the most traditional, holds to the idea that 3I Atlas is natural. A comet, yes, but a rare and complicated one, born in an environment our solar system has never seen. In this view, its oddities do not signal design, but unfamiliar chemistry, the fingerprint of another star's nursery. They imagine a small world forming around a distant dying sun, a system richer in nickel, poorer in iron, where unusual ices condense and metals bind in strange ways. Perhaps the compound we call nickel tetracarbonyl is not an industrial accident there, but a common frost, a natural state of matter under alien conditions. It is comforting, this view, that even the strangest visitor still belongs to nature's domain, that everything, no matter how odd, has a place somewhere in the galaxy's long history. Proponents of this natural but exotic model point to the diversity of chemistry across the stars. Spectra from distant disks show carbon monoxide frozen alongside silicates, metallic vapors condensing in impossible ratios. We have seen atmospheres rain, diamonds, moons of methane, comets of ammonia and tar. Why not one more variation? A nickel-rich world exhaling its unique breath. It would fit the cosmic pattern of abundance and variation. Every star builds its own version of what is possible, mixing elements as if composing its own music. In that vast orchestra, 3I Atlas could simply be an unfamiliar instrument, one whose notes, though strange, still follow the cosmic scale. In this model, its sunward jet might be a coincidence of geometry and opening near the pole aligned by chance with the sun during observation. The lack of acceleration, the balance of thrust, could be explained by symmetry of venting or by mass so large that no measurable shift occurs. Unlikely perhaps, but within the long patience of probability. Yet even among those who hold this view, there lingers unease. Because natural or not, 3I Atlas behaves with precision. Its emissions pulse at intervals too steady for randomness. Its brightness curves too smooth for chaos. Nature is capable of elegance, yes, but rarely so exact. It feels as though the equations that govern it are being solved perfectly without noise, without deviation. In the language of science, we call that determinism. In the language of poetry, we might call it grace. The second camp, smaller but persistent, looks deeper into that precision. For them, the question is not chemistry, but control. They wonder if 3Y Atlas could be something artificial, not a machine in the mechanical sense, but a remnant, a fragment of something once built. They do not imagine blinking lights or antennas. They imagine geometry, internal order, structural purpose. An object that once served a function and now, after ages of drift, merely behaves like design remembering itself. Perhaps it is a fragment of a probe, a discarded sail, a vessel's relic long cooled and inert, its self-regulating systems still whispering reflexively in the dark. Perhaps the nickel compound is not chemistry at all, but residue, a trace of engineered material oxidizing and releasing gas as it decays. This idea is not new. When Oumuamua passed through the inner solar system in 2017, its strange acceleration sparked the same question. Could it have been a fragment of something technological? The shard of an ancient sail? At the time, the notion was dismissed as romantic a story for headlines rather than equations. Yet, in the quiet years since the idea has not quite vanished, it lingers not as belief, but as curiosity. For if spacefaring civilizations exist, their debris must exist too. And what we call interstellar objects might simply be the flotsam of that invisible history. To the advocates of this model, 3I Atlas fits the pattern of age and precision. It need not be active or deliberate, only persistent, only well-made. A fragment of something that once understood balance and still through its own inertia obeys that long-ago design. Of course, the burden of proof for such an idea is immense. Science moves cautiously toward the extraordinary. For every whisper of intention, it asks for evidence beyond coincidence. And so far, no unmistakable markers of technology have been found. No heat signatures, no structured signals, no motion unexplainable by physics. Even the spectral nickel, while strange, could arise from unusual natural chemistry. There is no message in its rhythm, no encoded modulation in its light. If it is a relic, it is a silent one, its meaning carried not in communication, but in endurance. And yet, endurance itself can feel like language. A body that refuses decay whispers something about intention, even if that intention belongs only to nature's deeper mind. Between these two extremes, the natural and the artificial, lies a third theory, quieter, older, more metaphysical in tone. It sees 3I Atlas as a pre-solar relic. In this view, the object predates our solar system entirely. It was not captured from another star recently, but has been orbiting here for eons long before the planets formed a wanderer born from the same nebular cloud that birthed the Sun itself. Over billions of years, its orbit might have been perturbed, nudged outward, sent adrift only to return now by some slow cosmic coincidence. If so, its chemistry could preserve the earliest record of the solar nebula, a time when the elements themselves were still cooling, mixing, binding in primordial combinations. The nickel tetracarbonyl might not be anomaly, but ancestor a remnant of pre-planetary reactions that no longer occur in modern environments. To imagine this is to step backward through the history of time. Before Earth, before the Moon, before even Jupiter had gathered its storms, a small metallic body circled the newborn sun, then drifted outward into the cold. Frozen for 4 billion years, it carried within it the chemistry of beginnings. And only now, after an orbit so vast, it spans the age of continents, it returns. In that interpretation, the mystery of 3i Atlas is not technological or alien, it is ancestral, a relic of our own cosmic childhood arriving home after an impossibly long exile. This pre-solar relic theory has a quiet beauty. It ties the unknown not to another civilization, but to our own origins. It suggests that the boundaries between stars are not walls, but memories that the materials of one system can migrate into another, like pollen on a galactic wind. It offers explanation without alarm and wonder without fear. And perhaps that is why it resonates, because it allows the mystery to remain without needing it to belong to someone else. But even this gentle hypothesis does not escape difficulty. The object's interstellar velocity at entry was far greater than what a pre-solar orbit could produce. Its trajectory, though now captured, was initially hyperbolic, implying origin far beyond the Sun's gravitational reach. It is too fast, too foreign, too aligned with the galactic field to be purely homegrown. The relic, if it is one, is not ours alone. And so the theories orbit one another as faithfully as planets around their star. Each holds truth, each casts shadow. Natural, artificial, ancestral 3 mirrors reflecting the same light from slightly different angles. Perhaps in time, future missions will decide between them. Perhaps a probe will visit 3e Atlas, sampling its gases, measuring its density, photographing its contours. But for now, the debate remains an act of imagination science practiced in the soft light of uncertainty. And maybe that is as it should be. Because sometimes the purpose of mystery is not to be solved, but to teach us how to remain curious. Beyond the main schools of thought, other subtler theories shimmer at the edges. A few astrophysicists suggest that 3y Atlas may be a compound object, a binary fragment. 2 bodies fused by ice, their interaction creating symmetrical venting. Others explore plasma dynamics, proposing that the Sun's charged wind induces current within a metallic crust, creating electromagnetic propulsion that mimics thrust, yet balances itself. Some think of it as a self-shadowing comet, whose geometry causes alternating heating cycles that regulate its activity like a slow chemical metronome. Each idea adds color to the mosaic. Each offers a glimpse of how complexity can arise without intent. And yet, all must bow to the same quiet truth that 3i Atlas behaves with a poise not yet understood. The debate, though diverse, shares one undercurrent, a kind of reverence. Even disagreement feels gentle here, as though everyone knows they are handling something fragile, something not to be defined too quickly. Scientists do not argue loudly when faced with such vastness. They speak softly, each hypothesis like a candle offered to a great unlit hall. And beneath every explanation runs the same quiet heartbeat of humility we do not yet know. As the months pass and 3. Atlas drifts deeper into the dark. Its activity wanes, its voice softens, but the theories it inspired continue to orbit within us. Each reflects a different human impulse, the rational, the imaginative, the nostalgic. Together they form a constellation of meaning around a single point of light. Perhaps that too is a kind of balance, our own intellectual version of the mass thrust paradox. Ideas vented freely, yet all held steady by the gravity of mystery. When future generations look back on this season of discovery, they may not remember the debates in detail. They will remember the tone, the hush that followed the data, the patient light of telescopes waiting in dawn's air, the shared breath between knowing and wonder. Because in truth, theories are temporary orbits of thought. They rise, curve, and fade. What endures is the rhythm of inquiry itself, the calm turning of curiosity around an unanswerable star. And as 3i Atlas glides onward, tracing its long ellipse beneath the constellations, it carries those orbits of imagination with it, each hypothesis a faint glimmer in its wake of silence. You've traveled far tonight. Through light and shadow, through chemistry and orbit, through the patient silence of space. The world around you has grown quiet now, and so has the universe. 3i. Atlas moves still a dim spark, somewhere beyond Mars, gliding along its slow captured curve. No longer bright enough to dazzle, not close enough to see, but present steady, serene. Its breath of nickel has faded into silence. Its rhythm continues unseen. And even here, beneath the weight of our own sky, you can almost feel that rhythm. It hums softly beneath the air, beneath the pulse of the earth itself. A reminder that everything turns the stars, the planets our thoughts, our rest. The mysteries remain where they belong, not demanding answers, only offering wonder. Because the purpose of discovery is not always to explain but to listen, to sit within the vastness and let its quiet presence fill the mind. The night holds all things now, the planets moving in their invisible patterns, the traveler gliding in the dark, the faint echo of your own breath folding into the same calm rhythm. Even the sun burning far away seems gentle from this distance. Its gravity is not a pull, but an embrace, the way time itself holds us without asking anything in return. You are part of that stillness. Your atoms drift in the same light that carries the comet's reflection. The carbon in your breath, the iron in your blood, the nickel within distant stones, all shaped in the same forge that built the stars. There is no separation, only motion, only the slow, endless conversation between matter and light. So rest now. Let the sky be wide again. Let your thoughts recede like the tides. The cosmos will continue quietly, endlessly, in perfect balance. 3. Atlas drifts on, and so does everything, our planets, our questions, our dreams of knowing, all carried by the same current, all held by the same light. close your eyes and feel the slow turn of the world beneath you. Feel how gentle it is, how the universe moves without haste. Nothing is lost, nothing hurried. Somewhere far beyond the horizon, the traveler completes another fraction of its path. And here, you complete yours. A moment of stillness, a breath in the long orbit of time. The stars wait quietly above. The night holds steady around you. Everything drifts, everything rests. Sleep now and let the universe keep watch.